Hi, so I'm Mark Eijsermans. I'm a software engineer at Hootsuite, and I'm going to talk about going from Vagrant to production and how we do things and how we got there, and a bit of history and the reasons why we did what we did. So there's been an army of us here, about 20, 25 people. So you all probably heard of Hootsuite now, but for the camera, I'll just recap a little. We're a social media dashboard that allows individuals and organizations to coordinate their social media campaign. We're sitting at around 8 million users, about 40 people regularly committing code, and a very small ops team. We're about two-thirds on Amazon, and then our own private cloud, which is Cloud Stack, and at a modest request rate of about 100 million a day for Hootsuite, and then our link shortener, Howley, is about 70 million. So we're a LAMP app, and that's where we started, and it grew into a monolithic P2P web app. And so over the last year, we've been transitioning to Scala services, and this was pretty much our system in the beginning, and I think this is probably really similar to a lot of early stage startups, that you have 1, 2, or 4 devs working on a shared development server, and you're pushing code. At the time, we were on Subversion. We've since moved on from there, but that's how we release code. We would just tag it and then release it. So to us, that was kind of our original DevOps, because you had a small team, and that team was able to release whenever they wanted to. There was low overhead, and it was a simple process. And the people that were writing code were in charge of the infrastructure. So while later the team grew, the infrastructure grew, and that's where things started to divide. So only a few of the engineers knew the system well enough, and it was a complicated release process. We were only pushing code about every 2 to 4 weeks, and we were doing stuff like branching and pre-release code freezes. We had discussions about, what's the best day to release, like a Wednesday or a Monday, and I mean, like, seems kind of alien now since we moved on. But again, I think this is pretty common to a lot of people. And so this is where we are now. We've switched to Vagrant, going to automated build process, and then pushed out to our monolithic web app and various services. So we got the release count back up to about 6 to 10 releases a day, and that's for the web app, and on top of that, the services. Anyone can deploy. And time from commit to production was about 15 minutes. So with that, we also got a bit of higher understanding of our engineering team and understanding the infrastructure. So it feels like we're just keeping our head above water, but in reality, at times it feels like, well, we're not actually swimming. We're swimming in a lake underwater. We're drowning. Like, we're just this a massive amount of stuff that that we still need to do, and so many problems. And so we like to compare ourselves not to where we came from, but to where we're going. You're never going to get the perfect system, and but we have to come to an understanding of what's actually working, like how many things are automated, reproducible, that they're in the state that we want them to be in. So, I mean, when can we start feeling good about this? Because I don't think anyone here feels that they're at the state they want to be in. I don't know, is it 20%? Are you 50% of where you want to be? So, it's a journey. Pushing code from Subversion is how we started. Then we did a mirror in the cloud once we grew, and then that scaled for a little bit. Then we started artifacting. We started with FARS, which is essentially a glorified zip format for PHP, and then we moved to tarballs, and then Z-syncing those tarballs to the clients. And Z-sync is worked out really well. It's essentially rsync, but the rsync algorithm is taken care of on the client side, so it's a great way of pushing changes to like a large group of clients. And for Scala, we're using Debian packages, and I love Debian packages because operating systems have been dealing with this problem for a long time. They've been working on this for a while of installing and updating software. So you have pre-install and remove scripts, and you can get meta information of what the state of your system is in. And I've been trying to convert everything to this format. So again, our simple, very common deploy process goes from commit, Jenkins unit test it, create artifact, smoke test it with Selenium, goes to our deployment tool, and then now to production. And this is one of our internal tools for pushing code. So it gives a high level overview of what's going on. Sees what's been tested, who committed it, at what time, and allows you, once it's passed the test, to push it out. So when you do, it'll check to see if there's any schema change that's been made. And if there hasn't been a schema change, okay, well then it's good to be pushed. When you do, you get a log of the last several commits. And also some high-level overview of statistics of the system. Usually we've got some yellow bars that are showing release time. So if anything's kind of going a bit wonky with the graph, then you can correlate that with the release. And I think it's a pretty common setup. We also have red deployment, which is in case of an emergency, and everyone breaks the build at some point. And if you need to get a fix out really quick, you can bypass unit test and go from there. It's dangerous, rarely need to do it, but it's nice that you do have that in place. So to allow us to push code as fast as we do, everything that we do gets wrapped in dark launch, a dark launch code block. So you write code, you wrap it, and then the system will pick up that code and then insert it into our system here. And it allows you to release to an individual member, organization, groups of members, and basically everything that gets pushed out is wrapped in a code. So with that, we have a bunch of screens that are around our office, and it just gives us a good overview of what's happening. So Borat up there giving the thumbs up that unit test passed. We have the pipe. Usually that's somebody's face of who broke the build, what's on production, what's on, what's increased in PHP exceptions and notices. So we have a culture of when you break the build, you get an email, build failed, and then you respond to that to everyone saying, okay, I'm on it, I'm taking care of it. So you're there's a culture of kind of ownership there. And again, we've got quite a lot of boards that are around giving like some of our key metrics, and it's been really useful to have a lot of these screens up around the office, because it's not just the ops people that are keeping an eye on that, but it's everybody from from devs to managers to everybody. You can see if something's going wrong and being like, hey, what's going on with the board there. So we moved to Vagrant because working off of a shared development server is just absolutely painful. It's a very volatile environment. People want to try using new code or extensions or versions of libraries and languages, and it just breaks the system very often. And if that server goes down, then the entire team goes down, which is problematic. So we love Vagrant, and you get dev and production parity, and encourages people to actually go ahead and modify the system, experiment with any new library that they want to use. So again, our very common build process, and we use Ansible for configuration management. So when you update the Ansible for one of our servers, it goes through a build pipeline, build, Jenkins will create up the Vagrant box, provision it, image that machine, put it on an artifact server so that on the dev side we can go and then spin up that machine and it's already cooked. So you don't have to run a provisioner or you don't have to configure the machine. It's just Vagrant up and you're away. It's also really nice that you can trash the Vagrant box very, very quickly. If there's a problem, you don't have to wait for, when you destroy the box that it goes through the whole process. And for some of our servers, it still takes a while to configure them. Some of them sit around like 20 minutes, half hour to go through the whole process. So with that, we created a plugin which compares your local version with what's been stamped, with the version that's been stamped Jenkins. And it'll compare your version with what's on the artifact server. So you can go and check to see what the state is. If you're outdated, you can destroy the box and then re-up it. When we up a box, it calls out to an internal DNS tool and gets your username and applies a DNS entry for you. So it would be like mark.owls.hootd.com. And so internally in our network, we're able to access other people's Vagrant machines and see what they're working on. And if you're a JavaScript developer, it allows you to then maybe call out to someone else's sandbox, so you can kind of work across the network. And that's one of the things that we really liked about being on a shared box and a shared sort of Apache virtual host setup, is that you were able to look at other people's sandboxes. So we use Ansible, and yeah, I mean, it doesn't matter which configuration management you use, and these are reasons like why we like it. And what I think are important properties is that in the last couple of months, we've been going through the process of putting absolutely everything into our configuration management, because from 5 years ago we weren't using a system, and we've only been on it for the last 2 years, and so there's still a lot of stuff that isn't under Ansible. But so we've got a team, and I was able to get developers up to speed in a matter of days. Very simple with the YAML. It's declarative. It's an easy model because it's over SSH. And so the more declarative something is, I think the more it acts as documentation. I think that's a really important quality of configuration management. It acts as a source of answers about how the desired state's supposed to be. So going through that process of Ansiblizing everything, it's been interesting, and it's been an exercise of essentially digital archaeology. We've been going through and auditing everything that's been happening, and there's some good stuff that you'll find in there. There's gems all over the place. So just as an example, we're rotating logs on our application side, and but the server wasn't cleaning up those logs. So we're like, well, why are we doing that? Why not use log rotate? And then I was talking to people that, okay, well, we should probably do this change. And then we realized, like, well, most of our important logs, they're all going to Logstash, Elasticsearch, Kibana, and Hadoop. So these are kind of legacy logs. Like, who's reading this? Well, let's get rid of them completely. So going through and auditing your infrastructure gives you the opportunity to actually look at some of those things that get forgotten about. You get to see that there were some problems of having memcache on different servers on different versions, and over the course of several years, when you get at hundreds or thousands of instances, you're going to have some machines that are up in the cloud that you actually forget what they were for. Some developer spun up a machine, did something to it. They might no longer work there, and you are kind of stuck with this weird cryptic name. And what does this machine do? Is it important? Is it key to our infrastructure, or is it something that was a test and I can destroy? And you don't want to destroy it because actually some of those things were pretty important, and we just forgot. So we're we're partly on Amazon and private cloud, and with private cloud, just the way that it's a fixed price that we spin up as many instances as we need, and if they're not being used, they're only consuming RAM. So it's okay for them to be idle. Whereas on Amazon, we want to auto spin, and with some of the server configurations taking about half an hour to run from the start, it's too slow. So you want to create gold images, and if you keep it in the mentality of it being a caching layer to your configuration management, then I think it's okay. So we have about 200 server types, and that is really hard to manage because one thing that we've been good at is adopting and trying out new technologies. So hey, let's try out React and Redis and Zookeeper, and we kind of spin up a lot of stuff, give it a try, and a lot of stuff ends up in as part of our infrastructure. So it makes us kind of think about our stack, and to simplify things. So really we're trying to push towards generic appliances versus all these custom bespoke instances. And this is something really new for us, and we've only been doing this for like the last month, is putting devs on call. And we have a pretty strong mantra, which is learning happens in production. And production is still running at 3 a.m. My code is still running at 3 a.m. So as a developer, I'm kind of mixed on this because it's good. I know that it's good, but I don't want to wake up at 3 because that's that's been somebody else's problem from before. And this is it kind of makes me think of this quote by Alan Kay. So people who are really serious about writing, who are really serious about software, should make their own hardware. And I guess this was said in the 80s. And right now we're not soldering circuits anymore, but we're spinning up instances and connecting them together and dealing with networks, and and that is essentially building the hardware of a distributed system. Because once you go beyond one or two computers, I mean, we're dealing with distributed systems right now, and that's the hardware of our system. And I think that's how you can get developers on board with the idea of being on call. Is not that, hey, you built this, now clean up your crap. It's this is going to make you a better developer. This is going to you're going to be forced to understand the system because you want to prevent being woken up at 3. So these are some of the very early on lessons that we found. So is your tooling and your monitoring really effective? If only a small percentage of the team had been using this to diagnose problems, well, had that knowledge been passed on? So if there is a problem, can the people on call, can they actually SSH into the box? And we want to move eventually to the point of not having to SSH into it, and to be pushing towards immutable ephemeral instances, more like Netflix, where you destroy a server, you don't SSH into it. And throwing somebody onto a system that they don't know anything about, it sounds common sense, but I think that you have to ascertain how effective you're actually going to be with it. So with that, we've come up with a couple of ideas of creating essentially choose your own adventure cookbooks to give a starting point of how to diagnose things, and it's been a great way of documenting things. And create a registry of specialists, so you know who to contact. If Mongo went down, and who's our resident kind of Mongo expert, and I feel sorry for that person, but so is this working? And I don't really know at the moment. It's very new to us, and I think that it's going to take a long time to actually get developers to the point of being really effective. But it's making us think about all those things that have to be in place. So I think it's the learning process, and just throwing devs on call is not going to be immediately effective, but you will eventually get there. So we have a culture of working out loud. we're a social media company, so we use Yammer and a few other things like HitChat. And we tried RC, but it was a bit too siloed. Unless you're on that team and you're working on this particular feature or product, then a lot of information gets lost in silence. So, you know, for incidences we conduct 5 whys postmortems, and the results of that get screenshotted from the or photographed from the whiteboard, and then posted on Yammer, so everyone can see that. Everyone from sales to marketing to customer happiness, they get to see what's going on, and I guess we have to constantly think, does this need to be a private conversation? If it does, go and throw it on an email, and if it doesn't, then put it on Yammer. And it's been really great to see all of the interesting nuggets of information that people have thrown into a thread, because I'm constantly kind of amazed by how many people like chime in just at the right times. Like, oh wow, thanks for helping me out on that. So there's a culture of accountability as well. Like I mentioned, if things failed, own up to it. We're not you're not gonna get in trouble. Just own up to it and deal with it. And so we have a strong mantra of learning happens in production, because as Chris said earlier, staging lies. If it didn't go in production, it didn't happen. If you didn't take a photograph, it didn't happen, right? And that's where things really happen, is in production. So yeah, thank you.
So do you want to do some questions?
Sure.
And just before we do the questions, I'm going to get someone from Demonware and someone from Active State to come down and give their 1 minute. So do we have someone from Demonware? I think Natalie said, is it Ramon or anyone? There you go. And I think Jeff's coming down from Active State. So yeah, anyone got any questions?
Hi, you were mentioning that you're building Debian packages for the Scala applications.
Yes.
So what's your production servers and how do they pull? So are you exposing a Debian repository?
No, at the moment we're actually manually placing them on the server.
And then running apt.
And then running them. So that's something that we do eventually want to put in place, and it's come up many times, is that we've needed to have our own private app repository, especially when certain PPAs go down. That it stops us from getting a server up or provisioning a server, and that's also a great way of updating the code base. So
you're running Ubuntu or a mix of Ubuntu, Debian, or?
Yeah. So and then with on the Scala side, they're generated by SBT. So we've created an SBT plugin to then on Jenkins we'll go through, compile, and then build the Debian package from there.
And you open source that yet?
No, but I think that would be a really great candidate for open sourcing, and that's something that we really want to do, is take some of the stuff that we feel is appropriate to open source and actually to get out in the open. It's based off of, the SBT plugin is based off of an open source package, and then we've kind of modified it from there. So. Yeah.
And you also mentioned you have like a repository already with Vagrant. What repository is that?
Just a server which stores all our artifacts.
Just on the file system.
Yeah, exactly. And that also stores our Vagrant boxes. So we have maybe 20 different images for projects that get developed heavily, and that contains like an image of what's pretty much provisioned on production. So you don't have to go through the pain of provisioning a server every time you destroy the box and re-up it. It's problematic that we found that in the early days when we started using Vagrant, and there was only a few developers manually doing it themselves, that it just caused a lot of problems. A lot of things kind of went wrong with provisioning it every time that it was slow. So. Yeah.
I think he was first.
Can you hear me okay? Quick question. You'd mentioned that for schema changes, you handled them slightly separately.
Yes.
Can you touch a little bit on how that works?
It's a manual process of updating the schema. So, and that's something that we would like to find. And if anyone has any suggestions, I would really love to hear about this from anyone here of how can you put schema changes in through an automated process? And we haven't figured that out yet.
Actually, my question is the same thing. Like, how do you do a rollback on schema changes when you production?
You don't. Rollback is another SQL, another SQL patch.
Exactly. You had an item in your chart there. I think it said dash for deploy. Pardon my ignorance, but what's that?
So that's our internal tool for pushing code out. And what it is, this guy. So it's all these slides here. It's essentially a thin veneer on top of Jenkins. So it doesn't actually push the code itself. It just gives developers a high-level overview of kind of what's next in the pipeline to push out. So it allows people that are working on Jenkins, working on the pipeline, to modify things without interrupting what the developer is used to. So it's really just gravy on top of Jenkins.
The next question is, once you decide that everything's okay and you want to actually deploy to production, how do you ensure consistency across your caches and like memcache and everything that happens there? Do you kind of flush part of the caches?
No, we don't flush. So in our models, we have an incrementer that when the model the schema has changed, or the model has changed, you increment that number. So only those caches will essentially be invalidated. But we don't invalidate cache. We actually want to try and maintain as much cache as we can across releases, because we're flushing cache every time we release. Like, we're right now sitting at around 6 to 10 releases a day. But what happens when we get to 100 releases? And I mean, I've heard of some people releasing every like what Amazon's releasing it every 8 to 10 seconds. So you want to bust your cache every time you release. You can't do that. So it's only the select things that need to be invalidated get invalidated.
Does the app know about that, or how do you know which things?
Well, because in the model itself, you're incrementing sort of a cache value number. So the mechanism it's using the cache, you've got a new key, so you're no longer hitting the existing cache.
Okay, thank you, Mark.
Yeah, thank you.